Picture it, that vast, silent expanse of space. For generations, it's been humanity's ultimate frontier, a boundless source of wonder and a canvas for our wildest dreams. But let's get real. With so many pressing problems here on Earth, the whole idea of venturing beyond our atmosphere often raises eyebrows. Is it just an expensive detour from our responsibilities, a playground for stargazers? Or could it be that when we gaze out into the cosmos, we're overlooking something absolutely vital? Now, chew on this. What if the keys to safeguarding life on Earth, the solutions to some of our most stubborn challenges, and the everyday technologies we can't live without actually originated out there? It's easy to dismiss space travel as a pricey indulgence, like buying a sports car when the rent is due. But what if it's the unsung engine powering our modern world and the quiet sentinel watching over our future? And it's a valid concern. When our earthly to-do list is overflowing with urgent needs that demand our attention and resources, spending billions on cosmic adventures can feel like ignoring the leaky roof to plan a trip to Hawaii. We hear it constantly. Why aim for Mars when we've got potholes on Main Street? Shouldn't we clean up our own planetary house before visiting others? These are legitimate questions, rooted in a genuine care for humanity and our home. Too often, space exploration is portrayed as this grand, distant spectacle, like a blockbuster movie that's fun to watch but doesn't put food on the table for the average person. Public enthusiasm, once soaring like Apollo 11 itself, has certainly seen its peaks and valleys. Many question if missions to the Moon or Mars should really jump the queue ahead of more immediate, Earth-bound problems. This perception of space exploration as a luxury item, a treat for a privileged few, or a global game of King of the Hill, often overlooks the fundamental reasons we've always been drawn to the stars and why now more than ever that journey is essential. But here's the twist. This well-intentioned viewpoint often misses a crucial point. Exploring space isn't like playing hooky from our earthly responsibilities. It's actually a vital part of meeting them. It's not about abandoning Earth. It's about understanding it, safeguarding it, and ultimately improving life right here. Venturing into space is like throwing scientists and engineers into an ultimate escape room challenge. The hostile environment of space is a relentless pressure cooker for innovation. The sheer difficulty of operating where humans simply aren't designed to be forces us to stretch the boundaries of science and engineering to their absolute max. And the incredible inventions born from this high-stakes problem-solving don't just orbit overhead. They have a remarkable knack for trickling down into our everyday lives, often integrating so seamlessly we forget their out-of-this-world origins. Countless gadgets we now consider indispensable are, in fact, space babies born from the demanding needs of cosmic missions. That GPS in your phone or car, acting like an invisible, all-knowing co-pilot? It's a direct descendant of navigation systems built for space. Our power to track weather with pinpoint accuracy, foresee hurricanes, and monitor crop health, that US, largely thanks to a network of satellites acting like Earth US, personal weather reporters, and farmhands. Even the camera in your smartphone traces its lineage back to technology designed for capturing images in the void of space. But the cosmic gifts don't stop at gadgets. They reach deep into the critical realm of healthcare. Medical innovations sparked by space research are surprisingly common. Think of MRI and CT scans. Their clarity got a major upgrade from the kind of digital image sharpening first developed to give us those breathtaking pictures from telescopes like Hubble. It's like space taught us to see inside ourselves better. Light therapy, initially designed for growing plants aboard space shuttles, is now a beacon of hope, helping to ease the harsh side effects of chemotherapy and radiation for cancer patients. The International Space Station, ISS, with its unique microgravity environment, is like a special laboratory where the usual rules of physics are bent, allowing scientists to conduct experiments impossible on Earth. This has led to huge strides in drug development and understanding diseases. For instance, pharmaceutical companies have grown protein crystals in space, which is like giving molecules the perfect, undisturbed conditions to reveal their true structure. This has helped refine treatments like Merck's Keytruda for cancer, making it more effective and patient-friendly. ISS research also offers a unique window into the aging process, as microgravity and space radiation mimic some aspects of how our bodies age on Earth. We've seen implantable heart monitors, sophisticated ear thermometers, and even advancements in LASIK eye surgery technology that evolved from systems designed to meticulously align the giant mirrors of space telescopes like the James Webb. And telemedicine, now a lifeline for many, was honed by the need to monitor astronauts' health on long voyages. Allowing Earthbound doctors to assist with medical situations in orbit, a system now connecting doctors to patients in the most remote corners of our planet. The quest for the stars has also ignited breakthroughs in materials science, robotics, and artificial intelligence. Imagine needing to invent materials that can withstand the fury of space, extreme temperatures, and intense radiation. These supermaterials don't just stay on rockets. They find their way into countless earthly applications, from more durable gadgets to improved industrial processes. Memory foam, that comfy material in your mattress? It was first designed to cushion NASA astronauts. Scratch-resistant lenses? Another gift from the stars. The relentless pursuit of lighter, yet stronger materials for spacecraft acts like a rising tide, lifting the boats of the automotive, aerospace, and construction industries right here on Earth. Furthermore, developing robots for space missions, think of them as tireless, precise extraterrestrial workers for tasks too dangerous or delicate for humans, has dramatically advanced industrial automation, sophisticated surgical robots, and even prosthetic limbs. And artificial intelligence, initially trained to navigate spacecraft autonomously and sift through mountains of cosmic data, is now like a brilliant graduate applying its problem-solving skills to complex earthly challenges such as optimizing global supply chains or enhancing medical diagnostics. Beyond the immediate wow factor of new technologies, space exploration addresses something far more profound: humanity's deep-seated need for long-term survival and a sustainable future. Our Earth is resilient, a sturdy ship in the cosmic ocean, but it's not unsinkable when faced with threats, both from nature and of our own making. Gazing outwards doesn't just provide a mirror reflecting our world more clearly. It equips us with the very tools and knowledge to act as its guardians, safeguarding its future and, ultimately, our own. One of space exploration's most critical roles is planetary defense. Think of it as Earth's neighborhood watch program on a cosmic scale. The universe, while wondrous, isn't always a peaceful park. Asteroids and comets, like ancient cosmic debris, occasionally wander into Earth's path. A major impact is a long shot, but the consequences would be devastating. Space telescopes and survey missions act as our vigilant lookouts, our eyes in the sky, constantly scanning for and tracking these near-Earth objects, or NEOs. As of early 2025, we've cataloged tens of thousands of these celestial wanderers, and the search continues for even smaller, potentially hazardous ones. Groundbreaking missions like NASA's DART, which successfully nudged an asteroid off course, prove we're not just helpless targets in a cosmic shooting gallery. We can develop proactive ways to shield our planet. The European Space Agency's upcoming Hera mission will be like a detective, examining the DART impact site to help us refine our asteroid deflection skills. Initiatives like the UN-backed International Year of Asteroid Awareness and Planetary Defense in 2029 are all about uniting the world in this vital shared mission, like a global emergency preparedness drill. Space exploration is also inextricably linked to understanding and combating climate change. Satellites are like Earth's personal physicians, providing essential data for monitoring our planet's climate vital signs, tracking greenhouse gases, spotting deforestation, measuring rising sea levels, and assessing the health of our oceans and ice caps. In fact, over half of all climate data now streams down from these orbital sentinels. This comprehensive global perspective allows us to build more accurate climate models, much like doctors use test results to predict health outcomes, enabling us to foresee environmental impacts and devise smarter, sustainable living strategies. Moreover, the technologies developed for closed-loop life support systems imagine creating a tiny, self-sufficient Earth inside a spacecraft that recycles every breath of air, drop of water, and bit of waste, have direct applications for improving resource management back home. These systems are like blueprints for tackling water scarcity and waste reduction on a planetary scale. Then, there's the game-changing concept of using resources found in space, in situ resource utilization, or ISRU, which is like learning to live off the land on new frontiers. We know asteroids and the moon harbor valuable minerals and water ice. Mastering how to extract and use these resources would be like finding a cosmic treasure chest, reducing our reliance on Earth's finite supplies, enabling a sustained human presence far from home, and even sparking entirely new industries. Imagine lunar water ice being transformed into rocket fuel or life support for moon bases. It's like setting up a celestial gas station and supply depot, making further exploration more affordable and self-sufficient. Peering even further into the future, space-based solar power, SBSP, is shifting from science fiction to potential reality. This technology involves harvesting solar energy in space, where the sun always shines, and beaming it wirelessly down to Earth. It's like envisioning a giant celestial power plant providing a continuous stream of clean energy, which could revolutionize our approach to climate change and global energy demands. Several nations and private companies are actively investing in SBSP research and development, with initial test missions already underway. Finally, we come to what might be humanity's ultimate insurance policy, becoming a multi-planetary species. Earth will forever be our cradle, but establishing self-sufficient human settlements beyond our home world is like creating a backup drive for civilization. It could safeguard our species' future against global catastrophes, whether they're cosmic curveballs or self-inflicted wounds. This isn't about deserting Earth. It's about ensuring that the story of human civilization and culture has a sequel, regardless of what plot twists unfold on our home planet. Ambitious endeavors like NASA's Artemis program, aiming for a sustained human footprint on the Moon, are crucial first steps in this monumental species-defining quest. While the tangible benefits of space exploration are compelling, like a toolkit packed with amazing gadgets, its true significance digs much deeper. It resonates with something primal within us, that innate human spark to explore, to understand our cosmic address, and to venture beyond the familiar horizon. This quest for knowledge and the incredible inspiration it ignites is a treasure beyond measure for humanity. Space exploration is a powerful engine for education and inspiration. Those jaw-dropping images of distant galaxies from telescopes like Hubble and James Webb, the heroic tales of astronauts venturing into the void, and the audacity of missions to other worlds, they act like a super magnet for the imaginations of millions, particularly young minds. This inspiration is the fertile ground where we cultivate the next generation of scientists, engineers, technologists, and mathematicians, the STEM talents who are the architects of societal progress. Space missions provide a thrilling, real-world classroom, making complex scientific concepts not just digestible, but downright exciting. The sheer audacity of landing a rover on Mars or dispatching a probe to the solar system, its outer fringes, serves as a brilliant showcase of human ingenuity and perseverance, urging every one of us to expand our ambitions and reach for the stars in our own lives. Moreover, space exploration possesses a unique gift. It acts as a bridge between nations. Grand collaborative endeavors like the International Space Station, ISS, stand as luminous beacons, demonstrating what humanity can achieve when countries unite for a common scientific purpose, often transcending political friction. In a world frequently fractured by division, space provides a common ground where teamwork can flourish, fostering shared discoveries and a powerful sense of collective human achievement. As we set our sights on future lunar and Martian expeditions, this collaborative spirit will be more indispensable than ever. The forthcoming International Year of Asteroid Awareness and Planetary Defense is another prime illustration of this global synergy for a common cause: protecting our shared home. Economically, the space sector is no longer a quiet government campus. It's a bustling global marketplace. Valued at hundreds of billions of dollars in recent years, the global space economy is on a trajectory for explosive growth, potentially rocketing past $1 trillion within the next decade. This expansion is being supercharged by more affordable launch options. Think of reusable rockets as the budget airlines of space travel, along with the rise of compact satellites and a surge in private investment. This new space era is like a new gold rush, forging fresh industries, high-tech employment, and economic avenues in fields such as satellite manufacturing and servicing, launch provisions, space tourism, and ultimately, the utilization of off-world resources. The Apollo program, for all its immense initial outlay, is widely credited with returning its investment many times over through economic stimulus and technological innovation. Today, the commercial space frontier is rapidly expanding, with companies deploying vast constellations of satellites for worldwide internet access and enhanced GPS services, stitching space capabilities ever more intricately into the tapestry of the global economy. Ultimately, exploring the cosmos profoundly deepens our understanding of our own planet and our place within the grand cosmic ballet. Witnessing Earth from the void of space, that delicate blue sphere suspended in the vast darkness, imparts a unique and often transformative perspective known as the overview effect. It's like seeing your home from afar for the first time, suddenly realizing how interconnected our global family truly is and how fragile and precious our shared abode is. The quest for life beyond Earth, even if it were to reveal only ancient microbial traces on Mars or point us towards life-friendly conditions on faraway exoplanets, would fundamentally reshape our understanding of biology and our own place, unique or otherwise, in the universe. Every new cosmic revelation, be it a newly found exoplanet or a more nuanced grasp of universal mechanics, stretches our intellectual horizons and enriches the collective tapestry of human culture. The journey to the stars isn't merely about the discoveries awaiting us out there. It's profoundly about the transformation we undergo here on Earth as a result. So the next time someone shrugs off space exploration as a mere flight of fancy, remember the technology you're holding, the life-saving medical advancements, the planetary health checks from orbit that protect our world, and the sheer unadulterated inspiration it offers. What's your take? Do you believe the cosmic investment pays dividends? Drop your thoughts in the comments below. And if this sparked your curiosity, please hit that like button, subscribe for more explorations into the frontiers of science and technology, and ring that notification bell so you're on board for our next voyage into the concepts shaping our future. Space exploration, far from being an extravagant escapade, is a vital, intricate endeavor deeply interwoven with the very fabric of human progress and our enduring survival. It's the forge where revolutionary technologies are hammered out, enhancing our daily lives and safeguarding our health. It's an indispensable instrument for comprehending and shielding our home planet, offering pathways to confront climate change and stand guard against cosmic dangers. It's an expanding economic frontier, cultivating new industries and livelihoods. And perhaps most significantly, it's a fundamental expression of our innate human curiosity, a wellspring of inspiration, and a powerful catalyst for global unity. The challenges confronting us on Earth are indeed immense, but history teaches us that solutions often emerge when we stretch beyond our perceived limits, when we dare to lift our gaze beyond the immediate horizon. Investing in space isn't an either-or choice against investing in Earth's future. It is an essential, synergistic component of Sirikruit. The quest to explore the cosmos is, at its heart, a quest to elevate ourselves, to secure our collective tomorrow, and to grasp our ultimate role in the magnificent, unfolding narrative of the universe. It is, in a word, crucial.